So designing for application does not mean that you will not be supporting the other applications. But what it means is that when you'll be designing your network, you'll be designing it for data, or you'll be designing it for real-time applications, or you'll be designing it for location. And depending on how you design it, you may be supporting all of them or only part of them. In other words, if you design for real-time applications, you'll be probably supporting data as well. If you design for location, you'll be supporting location, probably also real-time applications and also data. But if you design for data, there may be some areas where you will not be supporting real-time applications because it will not work well. You'll be dropping packets, you'll have one-way audio issues, etc. And also you may have some areas where location will not be accurate. So what is a design for data anyway? Well, data in most cases uses a protocol that is TCP. And the idea of a good network for data is a good network where people think that the network is good. What does that mean? Well, that typically means that when you have an access point with communication, people are going to think that the connection is good when they are, for example, on the website, they click a link, and it takes a certain amount of time, not too much, for the page to load. But that not too much may be half a second or maybe a second. And TCP, with its sliding window, is very reactive to losses, which means that if you lose some frames and if you lose some packets, TCP is going to take care of resending those packets. And that means that when you design for TCP, you may have some areas between two cells where you actually have a drop in the coverage. And because of the TCP sliding window, the network may be still robust enough that it's going to survive these losses in those coverage areas that are missing. So when your user walks from one cell to the other, dropping some packets may not be an issue as long as this experience of the network where it doesn't last more than half to 1 second during which there is no communication is matched. And of course, as you get to the rest of the cell, as you keep moving, communication is going to be retrieved and you will be able to retrieve these packets that you've been missing in the coverage gap. So when you design for voice, you don't bother so much about the overlap between the cells. You may have a smaller overlap and you may be accepting some areas where communication is going to be bad because you understand that the protocol above Wi-Fi at layer 4 is going to take care of solving these issues for the user experience.